Hi, my name is John Crockmalney, and I've developed these visual tutorials to accompany any technical training format that might be delivered. In this presentation, we'll explore Ohm's law, what it is, and how it relates to electrical physics. We'll also review how Ohm's law is used and applied in electrical circuits. There are two learning outcomes associated with this presentation. Number one, relate Ohm's law to electrical circuits. And number two, calculating electrical terms using Ohm's law. As we may remember, there are three components making up any electrical circuit. They are a source of the power, electrical loads, and conductors. The graphic shown is an example of an electrical circuit. Notice that there is 120 volts of electrical pressure difference presenting to a load. A red lamp having 120 ohms of resistance. Under this diagram, notice that 1 amp of electrical flow is flowing through the circuit and illuminating the lamp. Covered in previous presentations, we understand that there needs to be a pressure difference to initiate any flow of matter. We also understand that the greater the pressure difference is, the greater the flow is going to be. The smaller the pressure difference, the slower the flow rate. If there is no pressure difference, there will not be any flow. We can also understand the relationship between flow and resistance. This relationship is an inverse one. The greater the resistance to flow, the flow rate will be reduced. The smaller the resistance, the more that flow will increase. Notice that either increasing or decreasing the resistance affects the flow rate, but does not affect the applied pressure of the system. Putting these facts together, we can come to a general understanding of the relationship among pressure differences, flow rates, and resistance to that flow. In this graphic, we can see that if there is no change in pressure difference, the higher the resistance, the lower the flow rate is going to be. With pressure staying at the same values, the lower the resistance, the higher will be the flow rate. Assuming that resistance doesn't change, the lower the pressure, the lower will be the flow rate. The higher the pressure, the higher will be the flow rate. Now, with no change in the flow rate, in other words, in keeping the same flow rate, if there is a decrease in pressure, in order to keep the same flow rate, there has to be a decrease in resistance. In order to keep the same flow rate, any increase in pressure will necessarily have an increase in resistance. Translating these facts to electrical circuits, we can apply the same principles to an electrical term. Voltage is the term used for electrical pressure. Amperage is the term used for electrical flow, and resistance is the opposing forces presented to that flow. Ohm's law determines and proves this relationship among voltage, amperage, and resistance, something we intuitively understand analyzing the fluid power circuits featured previously. Ohm's law also involves algebraic formulas of which, if we knew two of the three terms, we can determine the third electrical term. Ohm's law involves voltage, amperage, and resistance. There are three equations associated with Ohm's law. If we knew only the value of the two terms, we can use algebra to determine the value of the third. Taking into consideration voltage, this value is found algebraically by multiplying the known amperage of the circuit by the value of the resistance. Looking at the graphic at the left bottom of the slide, we can see the value of the three terms. Voltage is 120, amperage is 1, and resistance is 120 ohms. Knowing that the voltage can be determined by multiplying the amperage times the resistance, we see the equation to the right of the graphic. Multiplying 1 amp times the resistance of 120 gives us a value of 120 volts AC. In this graphic, notice that the amperage has increased to a value of 0.75 amps, presented to a load having 320 ohms of resistance. Doing the Ohm's Law formula for voltage, multiplying this 0.75 amps times 320 ohms gives us an applied voltage of 240 volts AC. Applying the Ohm's Law formula to determine voltage, the known amperage is multiplied by the known resistance. Question: what is the voltage of a circuit having 10 amps passing through a load having a resistance of 100 ohms? To solve this problem, set up the Ohm's Law formulas and select which to use to solve that term. In Ohm's Law, voltage is equal to the amperage multiplied times the resistance. By applying the algebraic formula, we find that 10 amps multiplied by 100 ohms gives us an applied voltage of 1000. Try this problem for yourself. You can stop this presentation to work the problem and continue to play when you arrive at your solution. Again, in reference to Ohm's Law, voltage is determined by multiplying the circuit amperage by the circuit resistance. 0.5 amps multiplied by 120 ohms gives us 60 volts. The second formula involving Ohm's Law involves finding the amperage of a circuit. In this equation, notice that this is found by taking the known voltage and dividing it by the known resistance. Amperage equals the volts divided by the resistance. In this slide, notice again the electrical circuit located at the bottom left of the screen. Voltage is identified as 120, amperage is 1, and the resistance is 120 ohms. If we didn't know the amperage, we could use Ohm's Law to find the answer. Amperage is equal to the voltage divided by the resistance. 120 volts divided by 120 ohms of resistance gives us a value of 1 amp. In this slide, we see 240 volts AC presented to a load having 500 ohms of resistance. Dividing 240 volts AC by 500 ohms of resistance gives us an amperage of 0.48. Amperage is equal to the applied voltage divided by the circuit resistance. What is the amperage of a circuit having 120 volts and applied to a load having 50 ohms? Stop this presentation and work out this problem. When you find the answer, continue in this presentation to check your answer. Ohm's Law instructs us to find the amperage by dividing the known voltage by the known resistance. 120 volts applied to a circuit divided by the circuit's 50 ohms of resistance gives us 2.4 amps. Stop this presentation to answer this question. When you arrive at the answer, continue the presentation and check your answer. The answer is 1.5 amps and is found by dividing the 480 volts by the 320 ohms of the circuit resistance. The third formula of the Ohm's law equations involves finding the value of the circuit's resistance when the voltage and the amperage is known. The value of the resistance is found by taking the applied voltage and dividing it by the amperage. Referring to the electrical diagram at the bottom left of the screen, we see 120 volts applied to a 120 ohm resistance load and resulting in a amperage flow of 1. Notice that to find resistance, we divide the known voltage by the known amperage. In this case, 120 volts divided by 1 amp of electrical flow results in a circuit resistance of 120 ohms. In this graphic, we see 240 volts being applied, resulting in 1 amp of electrical flow. Under this circumstance, 240 ohms of electrical resistance is being applied. As in this case, 240 volts divided by 1 amp results in a resistance of 240 ohms. To restate the point, Ohm's law is nothing more than a way to understand the relationship among pressure differences, flow rates, and the resistance to the flow. Memorization may be a problem for many people. Therefore, there might be certain aids that could help us remember the three equations identified with Ohm's law. The graphic located at the lower right of the screen could be of general help. Starting with the first equation to find voltage if amperage and resistance is known, we see that amps times resistance equals the voltage. Using the image at the lower right, we can cover with our finger the term we want to discover. Notice that the A and the R are side by side, suggesting multiplication. Here we can see that by covering the V for voltage, amperage and resistance are multiplied together to determine the voltage. In this slide, the second equation states that amperage is found by dividing the known voltage by the resistance. Referencing the image at the bottom right, covering the term we want to discover, we see that the V is above R, suggesting the necessary division equation. In this case, amperage is found by dividing the volts by the resistance. Finally, with the third equation, the resistance is found by dividing the volts by the amps. Covering with our finger what we want to discover, we see that voltage divided by the amperage gives us the resistance value. In reference to Ohm's law, only three equations need to be remembered. You may find that by using the image located at the lower right to be of easier remembering for the three formulas. As elaborated upon a previous presentation, depending upon the schools and the instructors teaching electrical physics, there are different names or terms associated with electricity. In my presentation, I tend to use the terms associated with commonly applied components, hence V for volts, A for amps, and R for resistance. Engineering schools may have different terminologies, but the equations stay the same. Volts is also indicated as the capital letter E, standing for electromotive force. Amperage identifies electrical current induced in a circuit and abbreviated by the letter I. Resistance terms stays with the same letter of R. Notice that by applying the image located at the lower right, the equation instructions remain the same. No matter which reference you may wish to use, the process involving Ohm's law remains the same. And again, Ohm's law is nothing more than the relationship existing among voltage pressure differences, resultant amperage flow, and the resistance to that flow.